So this problem has a little bit of everything in it. I really like this problem. It says that we have a wheel of diameter of 3 centimeters and it has a 4-meter cord wrapped around its periphery with no overlapping. Starting from rest, the wheel is given a constant angular acceleration of 2 radians per second. The cord will unwind in how much time? A lot of information on this. I'm going to go and draw a picture. So I have a wheel. It has a diameter. Has a diameter. This means that its radius, r, is equal to 0.015 meters. We had 3 centimeters, which is 0.03 meters, but that's a diameter, so my radius is 0.015 meters. And around that, I'm going to wrap a cord and pull it off, and this cord is 4 meters long in terms of how much cord we have. I'm just going to designate that by S. And we know that it starts from rest, so omega naught is equal to 0, and it has an angular acceleration of 2 radians per second. And we want to know what the time is for this thing to unwrap. Well, this is really nice. I mean, I'm dealing with a rotation. This thing's unwinding, so it's rotating. And I have an equation that gives me this, right? It tells me that my original, or my final angle that I get to, or the number of times I've turned around, is equal to the initial orientation of this, what is my original angle, plus omega naught t plus 1/2 alpha t squared. And this is really nice because I'm going to set my counter to be 0. I'm going to start at 0 unwindings. I know that my original angular velocity is 0, so I just get that theta f is equal to 1/2 alpha t squared. This is great. I have alpha. I want t. I get that I need how many turns this thing unwinds. So I need a different equation for this. So I'm going to look at a different equation. I know that if this thing unwinds, for every time it unwinds, I get 2 pi r amount of string that pulls, that unwinds off of it. Or I remember the equation that theta times the radius is equal to the path length that goes off. So I originally said that I have 4 meters for S, or I can say that theta is equal to S over R. Now when I get to this point, all I have to do is substitute in this equation for my previous equation, and I get S over R is equal to 1/2 alpha t squared. That's just using this and substituting in theta for theta f. Tells me that if I have a certain amount of string wrapped around the radius, this is how long it's going to take. So rearrange the equation, I get 2s over r alpha square rooted is equal to t, which is equal to, what are my values? My values are a value of 2, a value of 4 meters, a value of 0.015 meters, and a value of 2 radians per second squared. And I square root all that. And if I did everything correct, I plug this in, the 2 will cancel with 2. I have 4 divided by 1.05, so this is 400 divided by 1.5. 2 decimal spots over, 2 decimal spots over. And this is going to be square rooted, and it's going to give me seconds at the end. So 400 divided by 1.5, that's a little bit over 20. Say it's close to, well, let's see, what am I working out? 400 divided by 1.5 is equal to square root of 266. And the square root of 266, I would say, is on the order of 16 seconds. So not a hard problem to figure out. We just had to work through our kinematic equation for rotation relate the rotational motion to the translational motion, combine the equations, and plug in our numbers and solve.